So guys, I'm gonna do exercise number 5, which it says a town with a population of 12,000 has been growing at an average rate of 2.5%. Now, first of all, we have to set the formula for growth. So we're gonna have a formula for growth and a formula for decay, which is gonna be very similar. So for growth, we have, if we talk about population, let's write it like this. Where this would be the population at a given time. Time can be years, can be days, it can be whatever, okay? It's every time we apply the multiplier, okay? And the problem is gonna be set. This would be the initial population. And then this R is the rate, okay? The rate, and usually this is it's given as a percentage. So it says a town with a population of 12,000 has been growing at an average rate of 2.5%. So they're given this as a percentage. But when we put it in the formula, we have to put it in decimal form. How do we switch a percentage to a decimal? Okay, that's what we're gonna do right now. Okay, that's gonna be for growth, but for decay, it can be just a decay of population or whatever. Let's put it P equals P01 plus, sorry, and here, because it's decay, it's minus R. So that's the difference between rate and decay. This negative. For growth, every time something happens, if it's year, day, they're gonna tell us in the problem, we're expressing something that changes every day or every year or every second or whatever, okay? And these are functions. So because these are functions, instead, I think it's a lot better if we write like this, in function notation. Right, that's for growth, and this is for decay, okay? Now, let's look at this problem, and it says for this problem, a town with a population, let's redo it here, a town with a population of 12,000 has been growing at an average rate of 2.5%. Write an equation that models the population of the town. Okay, so we're gonna write this function. Again, this is growth, and because it's growth, we're gonna use the growth formula, which is population at the beginning, sorry, has been growing at an average rate of 2%. I guess that it means years, because it doesn't say, yeah, here determine the population in town in 10 years. So they're talking about years. So we're gonna use Y for years, okay? And then that would be the beginning population times 1 plus R to the Y, which is years. So now, how much is the initial population? 12,000. So we're gonna write this 12,000. And then how much is R? Okay, R is 2.5%, but because we have to express this in a decimal form, we have the way to switch from a percentage to a decimal, it's always dividing over 100. So we're gonna have 2.5 over 100 equals this point here goes 1, 2, right? So it's gonna be, this point is here, we have a 0 here and a 0 here. So it's after we divide, it's 0.025. Okay? So that means it's 1 plus 0.025 to the power of y. So here we go. Now, if in the problem ask us after determine the population of the town in 10 years, we'll have to write that y will be 10, so we're gonna have 12,000. And when we add this, is 1.025 to the 10. When we do this with the calculator, let's try it. Let's try this. So it's 12,000. So 12,000 to the times 1.025 to the power of 10. So we have is, after 10 years, we have 15,361 people. Okay. Okay. C, that determine the number of years until the population doubles. Okay. So here we have they're asking us what how many years is going to take until the population doubles. Okay. So if we have 12,000, if the population doubles, we're going to have how many? It's going to be A. Now we're doing B. This is A. Oh my God, A is in here, right? A, B, C now. C. Determine the number of years until the population doubles. So we're going to do 24,000 equals 12,000, 1.025. And now we want to find how many years it's going to take. So now we have to use what we have learned of how to solve exponentials. Remember that we must have something like b to the x equals y. B to the x equals y. Then we have x equals log base b of y, right? So that's the way it works, right? To change from an exponential to a log equation. So now, if we look here, we have the base and the exponent, but this is annoying us. This should go to the other side. How do we do this? We have to divide over 12,000. So that's the next operation. If we want to get rid of this 12,000, we have to divide over 12,000, right? And what we have is 24,000 over 12,000 equals 1.025 to the y. So you have 2 equals 1.025 to the y. So we have, now we apply the log, x equals, or actually y, because now the exponent is y. So y log of the base is 1.25 of 2. Okay, we do that with a calculator. So we have alpha f2 log base 1.025 and then 2, and it's gonna take 28 years to double. Okay, that's for C. D, determine what was the population 8 years ago. Nice. So 8 years ago, that's for the. So let's think about it. If right now it's 12,000, right? So how are we gonna get 12,000 if we rewrite the function? Okay, if we put 0 here, 0 to the anything to the 0, any base to the 0 is going to be 1. So if we put y0, it's going to be 12,000. So that's where we are now. 8 years ago, it's -8, right? So we have to put -8 in here to find out what was the population 8 years ago. If we do that with a calculator, and maybe we can use here, yes, we could use this. Oh my God, what I'm doing with the calculator, I'm sorry. So I'm gonna rewrite it again. So 1 times 1.025 to the power of -8. And what's the problem here? What I'm doing wrong? Maybe I need a parenthesis or something here. Oh no, I know what I did wrong. I put a minus, I guess, instead of I should. It's now -8. Okay. So we have 9,848. Okay, that's the population. 9,848. Okay, that's what we get with the calculator. So that's it. We did one problem that involves almost everything they will ask you, right? And then the next video we're gonna do DK.